everyone, to listen to me talk. I hope this is enjoyable and you learned something. I guess I've kind of titled this talk tonight Intro to Blockchain, kind of a web devs edition, or kind of towards a web devy audience. And so I'll just go ahead and get started. So who am I and why am I talking to you? I'm Ryan, and hey, hello everyone. I'm a full stack developer. I don't know why I put quotes in there, but terms are just strange, so however you want to define those things. I've only been doing this professionally for 3 years. I got my foot in the door through launch code. I did some programming analysis at WashU. I did some front-end development. Chris Schmitz, the awesome Chris Schmitz, and just recently I've started doing back-end development at a logistics company. It's all in St. Louis. And so this talk, let me talk about this talk for a second. Just a quick question, I guess, to the audience. Who here could explain blockchain to somebody in 5 minutes reasonably, or could explain it? Has it? Understand? Kind of me. Okay. Okay. So I'll try to. Okay, that's good. Because that's kind of what most of this is about. Well, that's what all of this is about. But I try to do some kind of live, kind of practical application type stuff towards the end. So this will be really helpful. That's cool. Awesome. If anyone knows a lot about blockchain, I feel like as I've kind of gone and learned this stuff, because I don't do professional blockchain development. This is kind of like a hobby that I kind of, or just something I got kind of excited about once I really learned about it. I feel like I've ended up with more questions than I have answers, and there are still some things, even in this talk, that I'm a little bit murky on. So I apologize if there are some things I have to hand wave about, but hopefully you'll get the core parts, and you'll kind of see what's going on with blockchain right now. So the first part, I'm going to talk about it kind of as a static data structure. So if you were to talk about just a blockchain, just in a freeze frame, moment of time, what is it? What are we talking about? The second part, which is more hand wavy because I'm a web developer and not a network engineer or someone who really understands HTTP and stuff, is kind of how it lives in the wild and how it actually works and why it works kind of. And then I'm going to try to do some live coding, so we'll see how that goes. Anyways, this was my disclaimer. I was kind of assuming that I'd have a super technical audience and I'd be the biggest idiot in the room, but let's see if this. So I just put that there to say that if all of the chickens turn out to be ducks, I apologize. If I explain things and it turns out to be not 100% accurate as the way blockchain actually works, that's try not to hold me to that, because there's a lot of stuff going on here. But anyways, so let's start with a definition of blockchain. If you had to give a one-word definition, if someone said, what is a blockchain? If I was only given one word, I would say a data store or a database. It is a place where data lives. If I got some more words, I would say it is a database that is immutable and decentralized. And I threw ledger in there, but we can forget about ledger for right now. But it is, it can't be changed. You write something to the blockchain, to a blockchain, and it's someone, you can't go back and change it, and it doesn't live in one server. It's not in one spot. It doesn't really work. Well, you could put it in one spot, but it won't really work. The technology doesn't work unless it's decentralized. And I think as you kind of put the parts together, you can realize that this is it becomes more interesting than just a database. The properties, when you think about it from from the properties that it has, it becomes a very interesting technology. It allows you to do more stuff than what a normal database would allow you to do. And so another part is that it's I think of it as kind of an organic thing too. with a normal database, it can sit on your server, like say you have a database that just saves forms or something, form entries. Like, it works as a database whether or not anyone's submitting a form. Like, it's just gonna sit there and it's gonna have all your forms there. Blockchains don't really work unless they're kind of people are actively have them and constantly updating them or constantly verifying them. They don't really work if you sit them on a server by themselves and just put them away somewhere. Like, it's kind of a living data structure. And so, does anyone know what I'm going to talk about first? Does anyone have an idea? Does anyone have any idea what this thing is? Does anyone use this? How many are most of the people here do software development or web developers, maybe? Like lion's share, maybe? Okay, so this is like, if you Google the word Git, you'll probably get an image like this. This is probably like first or second tier images. So the first thing I'm going to talk about is Git. If you work with Git and you kind of understand Git, you've got the first piece of the puzzle. There's your first step. So Git, before I get to this, Git, as web developers, we kind of use Git as version control. You basically make changes to your repository, and what we kind of use it a lot as is kind of how it interacts with another server or with a team. We want to make changes. We want to branch it, add changes, and kind of with the kind of push and pull and branching and merging and reconciling stuff like that. The kind of the active kind of updating and working with other people. I'm not going to talk. That's really helpful. If you know that stuff, then you've already got another part of the puzzle. It's very helpful. But not talking about that stuff right away. Git does stuff on your own system, on your own machine locally, that is pretty much a core part of what blockchain uses. And so it's kind of like under the hood, what is Git doing on your own system? And if you kind of understand that, you'll understand why why blockchain kind of works. So Git applies a cryptographic function to objects in a repository. So did I misorder these things? Okay, no. Okay. So I won't get too. That's a pretty big sentence, and so some of the stuff kind of gets big, and I'm going to try to condense it and use as simple terms as possible. We're not coming here to take an algorithms course or something, and I'm not qualified to teach one. So this is just something to know. Cryptographic hash function. So it uses this, and here's another thing. When you think cryptography, you think of security. I want to basically not allow someone to see something. I want to be able to maybe secure some data through a network or something, so that I know what it is and then the receiver knows what it is, but then it's hidden in transit or something. Git uses a cryptographic hash function on the objects locally without using SSH or TSL or TLS or whatever, locally for consistency and not security. It uses this essentially to know what's in your files, to know if changes have happened. There's a property of a cryptographic hash function, or many properties that make it very, very helpful and very quick when you do a git status or a git diff to know what's changed and where is it changed. So not security at all, but it's totally used before you even get to the network stage of Git. So cryptographic hash function is essentially a function where you put something in there and then you don't know what you're going to get. You have I give it a file, and I can't predict what the output's going to be, but I know that it's going to be whatever I want it to, within certain parameters. So a fixed length string of hex or something, and it's unique to that file. And if I make slight changes, I still don't know. I'm still going to be at shruggy stage. I'm still not going to know what the output's going to be. You can't predict it. It's not you can make little changes to it and figure out oh, now the last thing's going to go up or down a thing. The whole thing is going to change. And so this is just for time's sake, I might not do this, but if you wanted to see Git hash just anything, if you have a running Git repository, or if you're in a Git repository, you can run like echo and pipe it into Git's hash object function, and it'll give you a hash, whatever you echo in there. And if you do like hello, you get something, and you do hello1, you get something completely different. And you can also do this with just the, so it uses SHA-1, Git uses SHA-1, which is a hashing algorithm. And you can actually do the same thing with just a regular SHA-1 function. Most people will probably have OpenSSL if you have like a Unix, you're in a Unix environment, or I don't know. But you'll actually get something different with each of these functions because, but I'll get to that in a second. But let's get through some of this stuff. So Git under the hood. The stuff that I'm talking about locally in your repository. There's a lot there, but the two things I'm kind of interested in are blobs and trees. And I'll kind of show you what I'm kind of, right? So here's the actual repository for my presentation. So it's Reveal.js. It's kind of this cool presentation. Ooh. There we go. Is it? Come on, there we go. Command shift function. Okay, so here's the repository for the framework. It's a framework I use to make this presentation. It's called Reveal.js. It's really cool. You can write HTML and then it'll make slides for you. And you can do something called lstree, which actually, if I give it a commit, it'll give me an output that has like a file, essentially a binary large object. I'm not going to get into that, but anyone here can imagine maybe that a file at some point can be thought of as like a byte string. And here's like the hash for that, the associated hash. And so Git locally is going to be computing all of these hashes for every single thing that everything in your repository that it's tracking, and it's also going to be assigning things either, is this a blob or a tree? So is this like a node or is this like a directory kind of? And you can even, I can even go into like say my CSS folder and do that again, and I'll get the hash for the tree and the hash for the blob. Okay, and so with a hash for a file, it kind of makes sense. Like, if it's a byte string, I feed in like this byte string into the function, and I get the fixed length output. For a folder, it gets more interesting, and that's where the tree idea comes in, where essentially it takes, if you imagine L1, L2, L3, and L4 here as the files in your directories, the hashes for those trees are going to be, for the directories are going to be all this, like the files that are inside of it. So you're hashing, like these are going to have their own unique hashes, but then we're going to hash those, and this is going to be like a directory. So this would be like my CSS directory, and it's essentially the hash of like style.css and then style2.css, and this is maybe my JavaScript directory, and so this is like JavaScript 1, JavaScript 2, this is the hash for those, and then this is the combined hash, and then we keep going all the way up with our trees. So like when you kind of, if you've ever referenced a Git commit by its hash, that root hash is basically all of the things, all the hashes combined, and all the files and all the directories all the way up until you get to like the root. And it combines not only the contents of your files, but also like the modified times, but like the file names. Those are kind of done differently, just for kind of a speed reason. But modified times and like file names. And I think like your timestamp in the committer, the author, be involved in that. So this is a one-dimensional view. So this is your Git repository. Your Git repository essentially, and the thing to take away from this, even if you didn't really catch that or I'm talking too fast or whatever, is that all of the stuff in your repository, that git commit hash that hash is tied to everything in your repository. Any change anywhere in that repository is going to change your commit hash. So you can't the commit hash literally is like, it's like the DNA of your repository. Like any change, you can't get away with making changes and not have that hash change. So it's pretty unique. And so this isn't actually a Git repository. This is like a part of the blockchain, but this is like a really good picture for it. So so imagine this part right here. If everyone can see that, would be like your files, you know, in your directories and whatever, and this is your commit hash. Not only does Git calculate that hash from the repository itself, but from all the previous commits. So all the previous, like say this is a commit, everything that goes in that commit, that hash, is bundled up and it's calculated into the next hash, and it's calculated into the next hash. So not only can I not change files in my repository and not have the commit change, like the commit hash is going to change, but if you were to go back in time and change any other commit or change anything else in your own repository, it's going to propagate all the way forward. Really interesting property of this, and Git really just does it for consistency's sake. So it knows when you have that repository, that it has the exact same history, and someone hasn't been meddling with it, or the file is the file, and it's not some other file. So to recap, Git calculates unique hashes for objects in a repository. Unique star because, like, if you have a fixed length hash, like you could have hash collisions. So it's like reasonably unique. That one-dimensional view is that any changes to your data is going to change your hash, and any changes to your history is also going to change that. So that's the kind of immutable part. You can't change anything locally to your repository without having that change propagate all the way up to one specific number. And there's also a lot of computational benefits to that. So Git trees plus a bunch of moving parts is blockchain. So cool. You guys, good on time. So we did it. Cool. We did it. Awesome. Kind of. I'll skip that, but it's just that's data structure stuff. So it's not actually Git and blockchain don't actually use the same exact data structures, but the data structures have the same properties. DAG stands for directed acyclic graph. DD I think is deduplicated, so it's like it's weirder, and I'm not really good with tries, but it's got a try in there somewhere. Like I didn't research that, but I know it's in there somewhere. And now there's the whole, like, all the rest of the parts. Like I said that it was a living thing, so like you can't just have a Git repository and then it's blockchain. Like, but blockchain is like, I would say if blockchain was a technology, there are like 3 parts glued together. And if you understand this part about a Git repository, then you understand like what are the major parts that make this like make the whole thing work. And so a quick comparison, if we were just going to think blockchain as a blockchain as a data structure, as a Git repository. So if we're going to make a comparison, that a commit is a block. A commit tells you if you do a diff, then you'll see everything that changed. Everything that changed in your commit is essentially all the transactions in a block. Everything that changed from this state of the block to the next, or the blockchain to the next. The branches in your repository are the chains. So that master branch is like the thing everyone's tracking in like Bitcoin or like Ethereum or all those other like cryptocurrencies to essentially figure out, you know, who has what money. You know, like if that's basically the ledger, so everyone tracks the master. Sometimes, because I said blockchain's a moving technology, it's kind of living. So if multiple commits happen at the same time, which can happen, then essentially branches are going to start competing to be the master branch. And there's parts of the algorithm that just say whichever one gets the longest, the fastest ends up being the master branch. And so it's equivalent to branching. And then forks happen occasionally, so you can fork. Blockchains will fork. This happens usually when theft is involved or people disagree on major parts of the blockchain. This has happened a few different times, and you can probably have whole talks about that stuff. Anyways, so here's just another, if you're going to just look at like naive cryptocurrency sense. Like, here's like a Bitcoin blockchain. So this would be like the first hash ever. Some dude just gave himself a ton of money. He didn't have it. There's no history, so your hash before this is nothing. Nonce, we'll get to that in a minute. And then you have a hash because it, give me all the money and then calculate that, make it a unique thing. Then the next block is like, okay, let's start distributing out this money. That's kind of that. There's a transaction list here, so this would be like all the lines that you changed on your commit. And Merkle tree, that was from that image earlier with the angular Merkle in front of a Christmas tree, is the name for the Git repository data structure.
So those are 3 separate transactions, but they're all part of the same block?
Yeah, they're kind of, it's like lines in a commit diff or a Git. Okay, so transactions, adding the line to the next commit. So like, I'm talking about blockchain, but it's hard to talk about blockchain and not talk about cryptocurrency. So like, I'm talking about cryptocurrency too, kind of like, this is like the best, this is where it lives in the wild right now. There's not a whole lot of blockchains that really are really that popular outside of cryptocurrency, or really have the kind of, are as battle tested or live as a lot of cryptocurrencies are. So kind of like, there's a lot of like mixed terminology here, but like a transaction. So how do you add lines? How do you add lines to your commit, your block? Thinking of blockchain as like a data store. So it's immutable. One of the first things I said was it's immutable. Everyone has like read access. So you can read everything that's on there. You can read all the commits. You can read all the transactions that ever took place. You can see everything that's ever happened on there. Instead of like, if you think of like a row in a database, if we're thinking of this as a data store, instead of like somebody's name I give, Chris $20 or something, it's like a hash, a kind of, an address or kind of a hash gives a hash a certain amount of money. Rights are very special, and this is important because if it's immutable and everyone has it, you don't want to be able to have other people spend your money. Like, that's a big thing. It probably wouldn't work if you could spend everyone's money. Does that make sense? And if people do try to cheat, you should be able to detect it. So this was the video, and I think I'll have time, hopefully, that this talks about. So the first thing when I talked about cryptography, one of the things I talked about was not using it to hide things, but using it for consistency's sake. And here's kind of another use case of cryptography outside of just straight like obscuring something, is digital signatures. And this is what makes basically commits or lines in a commit, like the transactions work, that basically allow me to say I gave Chris $20 and no one else could say it. So I think this takes a second.
Part of this very simple system might look like this. Anyone can add lines to the ledger, and at the end of every month, you all get together and settle out. Now, one problem with a public ledger like this is that anyone can add a line. So what's to prevent Bob from going and writing Alice pays Bob $100 without Alice approving? How are we supposed to trust that all of these transactions are what the sender meant them to be? Well, this is where the first bit of cryptography comes in. Digital signatures. Like handwritten signatures, the idea here is that Alice should be able to add something next to that transaction that proves that she has seen it and that she's approved of it. And it should be infeasible for anyone else to forge that signature. At first, it might seem like a digital signature shouldn't even be possible. I mean, whatever data makes up that signature can just be read and copied by a computer. So how do you prevent forgeries? Well, the way this works is that everyone generates what's called a public key, private key pair, each of which looks like some string of bits. The private key is sometimes also called a secret key, so that we can abbreviate it as SK while abbreviating the public key as PK. Now, as the name suggests, this secret key, it's something you want to keep to yourself. In the real world, your handwritten signature looks the same no matter what document you're signing. But a digital signature is actually much stronger, because it changes for different messages. It looks like some string of ones and zeros, commonly something like 256 bits. And altering the message, even slightly, completely changes what the signature on that message should look like. Speaking a little more formally, producing a signature involves a function that depends both on the message itself and on your private key. The private key ensures that only you can produce that signature, and the fact that it depends on the message means that no one can just copy one of your signatures and then forge it on another message. Hand in hand with this is a second function used to verify that a signature is valid. And this is where the public key comes into play. All it does is output true or false to indicate if this was a signature produced by the private key associated with the public key that you're using for verification. I won't go into the details of how exactly it works, but the idea is that it should be completely infeasible to find a valid signature if you don't know the key. Specifically, there's no strategy better than just guessing and checking random signatures, which you can check using the public key that everyone knows. Now think about how many signatures there are with a length of 256 bits. That's 2 to the power of 256. This is a stupidly large number. To call it astronomically large would be giving way too much credit to astronomy. In fact, I made a supplemental video devoted just to illustrating what a huge number this is. Right here, let's just say that when you verify that a signature against a given message is valid, you can feel extremely confident that the only way someone could have produced it is if they knew the secret key associated with the public key you used for verification. Now, making sure that people sign transactions on the ledger is pretty good, but there's one slight loophole. If Alice signs a transaction like Alice pays Bob $100, even though Bob can't forge Alice's signature on a new message, he could just copy that same line as many times as he wants. I mean, that message-signature combination remains valid. To get around this, what we do is make it so that when you sign a transaction, the message has to also include some sort of unique ID associated with that transaction. That way, if Alice pays Bob $100 multiple times, each one of those lines on the ledger requires a completely new signature. All right, great. Digital signatures remove a huge aspect of trust in this.
Okay, so it's kind of hard to catch all that in like one time and just like totally get it. If I was going to boil that down, I would say that if you've ever used like RSA encryption or public and private key encryption, I guess it's Diffie-Hellman, I don't know, like it's one of the two, so one of those two. Yeah, it kind of seems familiar, having a public key that you put up on a server somewhere and keeping your private key in your .ssh directory. And then it's kind of you use that a lot in Git, or exclusively, or at least, I don't know if it requires it. But key takeaway from that, you have a private key. So your private key is like as like, important to being able to like to your like any type of like digital account as like your credit card number. Like if someone gets your credit card number and your information, like your social security number, like they can start spending your money. If someone has your private key, they can essentially transfer all of your money to them, and there's really nothing you can do. Likewise, your public key in this scenario is used to basically say, hey, this was this guy, he made this transaction, it's legit. And in order for this person to have faked this without his certain private key, you would need like multiple dimensions of like computing power. That's just like ridiculous. It's not going to happen. So like, yeah, private key is really important. You hear stories about people who had like a ton of Bitcoin and then like lost their private key and lost potentially what is like millions of dollars now because they just, I don't know. So it's kind of unfortunate, but also not that unfortunate because it's like digital fake money. I don't know. No, I don't know. That's kind of funny. So then there's the other part, and this is probably the most hand-wavy part for me because there's some parts of this like really, I'm not like a peer-to-peer expert, and it gets out of my depth pretty quickly. But you can explain it really easily, and you don't have to understand a whole lot about networks. So here's a cool quote that the co-founder of Ethereum wrote is that blockchains are politically decentralized, so no one controls them, architecturally decentralized, no infrastructural central point of failure, but they are logically centralized. There's one commonly agreed upon state, and the system behaves like a single computer. So the blockchain itself is like that single state. It is the ledger that has all the transactions and everything that's had, everything that has happened, like it's a state history. It's like just a complete history of what's going on, and it's constantly being appended to, but it doesn't exist in just one place. Like, it requires tons of people to have it at the same time, and everybody trying to like add blocks and update it and have the like most recent version and communicating with each other for this to work. So like, if you think about like a database at like Facebook, I mean, they're not gonna have like one data center, they're gonna be distributed, but they're gonna have like only a few of these, I don't know how many, but maybe 5, I don't know. Somebody might know more, but like, it may be like if you work at not a huge multinational corporation or something, or just a huge corporation, you may have one data center where you're handling all your traffic. And so this may be your kind of infrastructure. And so you have a central point of failure. If somebody, gets into your server or gets access or has access to your databases or anything like that, that's a point of failure. Like, if that goes down, you are doing damage control or bad things. This is a lot. This can be dangerous, I guess. This is kind of what blockchain looks like. Like, everybody has it. Everybody has all of this like secret data. Everything is just completely out there, and the idea is that because it's encrypted and you can only kind of there's only certain ways to decrypt some of this data. Like, it can be out there. So like, when I think about this was kind of the concept that really got me interested in blockchain, was the idea that I guess I had just started getting into using Vue with Chris, and so like totally switching gears, where we started doing a bunch of kind of, I don't want to say business logic, but a lot of logic in like the UI, a lot of being able to handle a lot of like application development in the front end, and I had also done kind of a lot of API work before that, where it was like my APIs are just like thin wrappers over database, operations. And so what was really interesting about this to me is that if you no longer have to, the most like central part and reason why you have a server is to handle all of this kind of logic and everything. If you can all of a sudden not put that on one server, and you can have that REST API and that database just decentralized and out there, then all you really need, you could essentially build you could build apps where all you need to do is pass around JavaScript, like UIs, that hook in to these decentralized data sources, and you wouldn't need a server anymore. That's like really serverless. Like, there's like serverless now where it's like, actually on a server, but you only make functions. But this is like completely serverless. Like, your server is like all these, well, not completely serverless, like it has to be on a computer, I guess, but like it's not centrally server full.
I've actually seen this similar diagrams, but they're not really focused on the physical networks, but more logically. So
Yeah.
the network on the left, you said Facebook, even if obviously Facebook doesn't have just one data center,
Yeah.
that would still represent Facebook as the entity, kind of being the source of truth.
Yeah.
So all those other little dots are, peons
These
with Facebook, whereas on the right, you have multiple sources of truth. And so, and I see that a lot with the banking industry, and they talk about Bitcoin and blockchain, disrupting that, and like, okay, yeah, you're relying on U.S. Bank to tell you how much money you have, because the U.S. Bank tells you no, then life is tough. Whereas on the right, if your money's in Bitcoin or whatever, you got all these other sources of truth. So
Yeah.
Obviously, no one server has an entire copy of the blockchain, so it's distributed. And I would think that
So that's an interesting question. I don't. So let me.
It's 51%.
That 51% kind of refers to the 51%. Kind of a common problem that a lot of blockchains have to solve that has to do with computing power. As far as like taking down nodes, like so, the premise of that was not everyone has all the blockchain. You can have all of the blockchain. Like if you wanted to host a full node of, I don't know what Bitcoin is at right now, but if you wanted to host a full node of Ethereum, it's like 200 gigabytes, and you probably need like 2 gigabytes RAM. So like $20 a month on DigitalOcean plus whatever your volume is or whatever. So it's like, it's feasible, it's large, and to be honest, like if you don't own a lot of Ethereum, like that's not very beneficial to just like help out the network by being another node. But the thing is that there are like half nodes too, like people that don't have all of it. Like think of these dots as people connecting to people that have all of the data. And people that have all the data are constantly trying to get the next, like the latest updates. And so it's less about taking out like these nodes, and then it's more about the network being too small. Like if it's too small, then people can kind of dominate the thing. And with the 51% too, like if it's less about taking out nodes, like that's not as scary because with the larger, I guess, cryptocurrencies, like they're already really big. It's more about people owning too much of, less about like terrorists or something, and more about like large entities like nation states or something. Like I think Bitcoin actually is approaching this problem with Chinese cryptocurrency mining, where the Chinese own so much of the computing power that they could essentially start gaming the system, and they have so much power they can overpower everyone else and start putting false data, and you just accept it.
Of course, China, the government there has prohibited people from participating in that. But blockchain has other applications besides cryptocurrency, and that's actually what I was thinking about. I mean, the whole blockchain thing, if somebody has inventory system or something like that, it could be a problem.
I think that in part with that, I think that even you can do a lot of things where you pretty much run your inventory system on another larger blockchain, so like a side chain kind of. So like say I want to start my own like coin or something, or I want to start my own like Ryan's data, like one of the best ways to do that is actually hook that into things that are already very large and secure. But yes, if you do, I mean, you'd be very vulnerable if you had a very smaller blockchain and you weren't like encrypting monetary transactions. Say you were, like one thing I think could be really, really interesting is if people were doing this for like healthcare data. Like what if instead of like all of your kind of like, scans or like just reports or anything were encrypted into like this immutable ledger that you could temporarily, with a lot of other bells and whistles, I mean, on top of just a standard blockchain, give access to like your next doctor or something, so that I wouldn't have to go through my doctor, my insurer or something. I would just have this like, I could temporarily give whatever my next primary care physician is like access to my records and revoke those when I want. Like if that was like, that's something that you'd want to have be on a large enough network so that wouldn't be vulnerable to like people essentially falsifying things or being able to spread a false history or spread falsify commits. Because I think the idea is that it's not so much taking things out as it is like cheating the system in the future because you're so powerful is the real concern. And when you're a small network or you have big actors, they can have undue influence on the state of the blockchain. So, did that kind of answer?
No, because actually what I was thinking more of is that if there's a copy somewhere, a full copy, that means there's an access to all the links. So it could then go and find where all these other distributed nodes are and possibly infect those or disrupt them.
Well,
And of course, I'm not saying that it's going to create false information within the blockchain, but rather simply disable it.
that's something that I think there was even a little bit of talk about kind of security on the blockchain channel at STL Tech today, where that's a concern, and that kind of has happened before, where people found vulnerabilities, and since it's a peer system, nobody's like filtering. There's no traffic cop there. There's nobody who's saying, oh wait, this guy's doing malicious activity. We got to shut all these down, and they can't, or they whitelist these or blacklist these or whatever. Like, if you do find a vulnerability, and you can start exploiting that, then yeah, like you could definitely just shut things down or taint whatever you want to do. Does that
Yeah, that's
closer?
along the lines of what I'm
Okay.
disabling or disruption of the blockchain, not necessarily changing the information, because obviously
Yeah.
that is too hard, but it's still vulnerable. And
Yeah.
we just bring it down.
I mean, these are all developers. Like, these are the people that are doing blockchain aren't like superhuman. They're just I don't know anyone who hasn't written like a bug at some point in their life, and so definitely.
So there's still definitely like vulnerabilities with a decentralized network, but there's general agreement that those vulnerabilities they are fewer than there are with a centralized network. It's not like vulnerability with decentralized versus some system with no vulnerabilities. Is this less vulnerable to attack or to like disruption or outright taking it down than centralized? Like, because if anything that you can do to a decentralized system, you can probably do more quickly and easily if you can get into the centralized one.
Yeah. And all of the code for these protocols and everything, that's open source. So, like, it's easier for people to fix these things when they happen. And also, I mentioned forks earlier. There have been hard forks when, like, vulnerabilities did very, like, bad things to networks. Like, Ethereum's a really good case. They made something called a decentralized autonomous organization, and it's hard to explain, but it was like a special kind of interaction on the Ethereum blockchain that they had that was whatever. But somebody was able to expose some code in that software and steal millions of dollars in Ethereum, and a lot of that was from, I think, people that were a lot of the Ethereum developers and just a lot of people in the community, and they decided to do a hard fork. And they basically said, okay, we realize that this history in the last like week or so has been completely poisoned by this guy who just kind of stole, and exploited vulnerability to say, give me all the money, And so they said, like, we're going to go back, and then this is the new history. We're going to patch that, and then this is the new history. You can literally, like, fork reality, kind of, in a way. Like, so now there's, like, two competing. Ethereum Classic is still out there, and it's, like, trading at, like, $6, and Ethereum's at, like, 178. So, like, there's people that are like, no, there was a vulnerability, and that's what we believe it should be, and so we're still going to append to this chain. And then, like, a large portion of the community is like, no, we think that's illegitimate, like, that's a lot of stolen money. We're going to go with the patched branch, essentially, and we're going to treat this like Ethereum. And so essentially what happened was the value of, like, the people that stole stuff, their Ethereum tanked, and the people who patched it, their Ethereum is still at a...
But there are still like special decision makers who alone have the ability to create that fork. They can make that fork, and then we all vote on it by deciding which one to follow, or can anyone...
It's kind of like you vote with your dollar or your node, kind of. You vote with whatever you decide to interact with. Like, they could have done that, and people could have been like, no, you screwed up, and, like, that guy stole your money, but rightfully so. Like, slap you on the hand, we're going that way, Like, people, you vote with your actions, kind of. Like, there's no, like...
But there's still decision makers that put it on the ballot. Is that what you're saying?
There's no, like, ballot. It's more like, I'm doing this and I'm doing that.
Yeah,
I guess.
I understand it's breaking down. Someone decided this is false, we're going to create a fork, or can anyone say this is all BS, I'm making a fork?
I could fork Ethereum right now.
Okay, and then I could say, you know what?
This is the guy, and it would be me and you. And it would trade at like $2 or 10 cents, and it would be like, what is going on here? Like, no, but yeah, you basically, anyone has the power to totally control this thing. I think that you could probably make a case that sometimes co-founders have more power in the development of the protocols to do things. I think that's a legitimate argument. But in theory, in a perfect world, you should, as a developer, have as much power to, or even as somebody who's choosing with their kind of dollar or their votes to influence how the direction of things. Is there another question? Or, okay. So I guess we're on the network. So talking about the network. Okay. So just I'm gonna just we're getting to like one of the most important parts, and I do want to do some coding, just a little bit, and see, just so we can see that the stuff actually exists and play with it in the wild a bit. So I'm gonna do some, but just wrap up what's going on here. I signed that transaction. I want to get $100. I send it to a thing called a transaction pool. It's just a place where like transactions live, where they're just like waiting to be commit, like lines in a commit diff live that are waiting to be put in the next commit. And so there are things called mining nodes, which constantly want full copies of the blockchain. And then there are full nodes, which are kind of just full copies, but there's no mining going on. You're not trying to add anything. I have the state. I just want to have the latest state. It's like a mini little bank. Like it's like what are the things that are not banks, but banks? Community banks? Community credit union or something? Kind of like that. Like I can submit your transactions and stuff, but I'm not going to wrap them up into commits, into the next block, essentially. And then thin nodes are like, I'm not sure if I run one right now, I don't know about these, but it's basically like I only have gigabytes and have to run a full node, like a dedicated server or something. It's just like I want a thin server that's just reasonable. So mining. This is the thing that actually made all of this work, kind of, and it's one of the trickiest things to kind of get. But essentially, imagine you were somebody who had a full copy, and let's just hand wave and say that verification happens with that original data structure. We can verify things very quickly. That's one thing that it gives us. We can pull transactions from the transaction pool, and then we want to commit. We want to basically do a bunch of math problems, and we're going to do these math problems that are really computationally expensive, and like right now it's just like crazy how much computing power you have to do these things. But the idea is that I'm making like the root commit that you would normally have with this next commit. I'm making that top commit, but I'm adding something in called a nonce, which I think is short for a number used once. And what you do is you vary that nonce over and over and over again, and you want to get a special looking number. And the number that so I said way back at the beginning, just to have a fun little trek back in time, you get a lot of these guys, like you get the shruggies. You don't know you put a bunch of stuff in a cryptographic hash function, you're going to end up with shrugs. Well, imagine I wanted a shrug, but I wanted the number to start with the number 0. And if it was a hex string, a fixed length hex string, I'd have like a 1 in 16 chance, essentially. Like that's pretty good. Like that would happen pretty quickly. But then imagine I wanted it to start with a 0 and then another 0. So I'd have my 1 in 16 chance times my 1 in 16 chance. So I'd have to run like whatever that number is that many times, and on average I'd get it's like 144 or something. No, 250. Oh my god, I'm sad. 256. 1 out of 256 hashes, I would get a leading 00 result. Add another 0. 1 out of that times 16 again, and then like imagine you have like 15 zeros or something. You're going to need like a trillion hashes per second to have a 1 in whatever chance. And so that's kind of where we're at now. Is like the idea is you're doing this really hard math problem, and so you have to use a bunch of computing power. You're bundling everything up, and you're saying, hey, I'm getting this, I end up with this special number. And this special number will give you this leading zero result for if you hash it all together. And so when I get that, it's trivial for me to verify that. I put the leading zero result, I put the number that they used, I put the commit hash for all the transactions, I put those together, and then I just run a single function, takes like a nanosecond or whatever, and then I get that leading zero result, and I'm like, thumbs up, good job. Like that's legit. But it took them a ton of work. And the whole idea behind this, and this is just a proof of work system, the whole idea is that this person just worked really hard and used a ton of computing power in order to put this thing together. So it pretty much protects against kind of DDoSing the network. Like if I wanted to do put a bunch of cruddy like blocks out there, if I didn't have to do any type of like work or anything, then essentially I could just like, spam as much as I could out there, and then people would just be like, okay, this is the thing, and then like somebody eventually, full nodes are gonna start verifying. It's like, wait, these don't add up. This doesn't add up. This is bad, But basically, if I get that, if the first thing I check is did this person give me a correct, hash or whatever thing I can hash, then I can verify, this person just put a ton of work into this. So you couldn't do this like over and over and over again really quickly. Like they can't like spam this, and so essentially, as long as the network is large enough, and you don't have that 51% that you talked about earlier, it's pretty much infeasible that someone can start making cheat the system, kind of. Like I can easily verify that this person's put a ton of work in if they give me this number, and then I'd much rather spend my time making sure that's good. Like if they're going to put that much work into it, then like if everyone spams at once, then I'm just I'm getting all these like blocks, and like people can put a bunch of garbage in there and without a bunch of work, and like, go ahead.
So, I mean, it takes a lot of work to get a legitimate zero result, but is it relatively easy to make like a submission that is an illegitimate leading zero result, and then make everybody do a lot of work to verify that it's illegitimate?
I think they're called one-way functions in math. It's really, really easy for me to verify that. So I can calculate, if they give me the block and it has a list of transactions, I'll calculate the Merkle root myself. Like I'll just do that to make sure that this is legit. Like this thing hashes the correct hash, and then I can check using their number really quickly that I got a legit leading zero result, and then I know that as long as they didn't give me a bunch of like, let me see if I can explain this better. It's almost impossible to give you something that looks like even a block with the correct nonce and have a correct leading zero result. Like if you try to fake this stuff, you'll end up with a bunch of garbage. You can only do it like with garbage. It really like won't work. Like how do I explain this?
I think I misunderstood that because you had said, well, the work they have to go through this work as sort of a preventing of a DDoS thing, but it seems like you can generate tons of illegitimate data very easily and force the same amount of work to, like you're saying it's easier to verify illegitimate work than to verify legitimate work?
It's easy to see that someone has given me a block, something that looks like a block, and then a number, and it's very easy to compute that that's got a leading zero result and that's thumbs up, than it is for someone to try to give me a special number and then a fake block, just like a faked block that has that leading zero result, because I'm getting, if you have the hash function, you're always going to get the shruggy thing. You're never going to know what you're going to get when you jam data in there. So if you start to jam a bunch of false data in there, you literally could take something that's not any transaction or anything. I could take a bunch of just random file data and throw it in there, and I'd end up with the same amount of chance of someone who took legitimate data and hashed it through there, because they don't know. There's no way to game the hash function. Cryptographic hash function, there's no way to know what you're going to get. You just have to keep doing it. So there's no way to put, like, if you did put, like, cruddy data in there, you're kind of, like, wasting time because you're, in the end, you're going to end up with the same amount of chance as someone who put legit data in there. And,
But you're talking about the generation part, not the verification part.
verification part, it's really incredibly simple to verify, and it's incredibly simple to verify. It's just like when you run a function and any like arithmetic function, it's pretty quick to see. It just uses, it's like a lot of modular arithmetic. It can get done really quickly and see that this is a legit nonce, legit transaction list. And I know that someone's done a lot of work, regardless if they put false data or legit data in there. I know they've done a lot of work to get that leading zero result. So if I run the data that they gave me and the nonce that they gave me, and I get a leading zero result, the one thing at least that I know is that they put a lot of work into this, whether it's fake data or real data. I know that somebody just, has spent, what is it? Like the average Bitcoin mining cost is like, energy cost could like power a house for a day, which is insane. But it's like, at least I know someone's done a lot of work, so it's not like they can't just like, oh, I'll just game something really quick and throw it out there. There's nothing you can get around with this taking a lot of time for you to make one of these.
She was saying if I set up a bunch of these mining nodes and made up a bunch of crap blocks that didn't have leading zero results and sent as many as I could to you, like set up a big.
I can.
And I sent like whatever, millions,
Mhm.
billions of them to you. I can't send enough of them to jam up the system, checking to see that even though they're all garbage, checking to see that these are all not leading zero result blocks.
I mean, I guess that's kind of like a network question, like a peer-to-peer network question. Like, basically, it's almost like if someone, at that point, that's where the decentralized part comes into play. That's really helpful. So you send that to me, and you can take down my node easily then, because I'm gonna sit here and I'm like, oh, this is crap. This has no leading zero result. He's sending me garbage. But you're just sending that to me. There's this whole other network that I'm just not passing it on to.
And like, what's it when like you scale up the ability to process all that information immediately? Or I guess I could take you down, or I could just send everything and then it can handle it.
Yeah. The thing is that I wouldn't pass it along, so that essentially you just take one part of like it's essentially the same idea behind Napster and BitTorrent. Like, you can kill someone's computer that's running the BitTorrent client. That's not going to take down the BitTorrent network. Like, there's just nothing you can really do besides like tracking down all the people that are like seeding whatever, like, and if the network's big enough, it's kind of impossible. Like, that's the idea, is that I'm not, like, basically the filter is that I'm not saying, hey, this guy's giving me legit data. You're just taking down all the traffic. You're killing my node essentially, but by killing my node, I'm kind of sparing the rest of the network from garbage traffic. I'm not saying, hey, here's the latest thing. And people are incentivized to have the latest thing because miners really want it, because they want to be able to have like the latest up-to-date data so they can quickly mine another block and because you get money for mining, essentially. That's the idea behind mining, is you get money for each one that you add to the chain. So this is a really complicated thing, and this has taken me the longest time to understand about it. But I guess the idea is that without this, you can kind of spam and break the network. There are better ways to do it than proof of work. I feel like we're in the stage where like somebody's like, I feel like with proof of work, it's like somebody riding by on like a horse and buggy or something, and like, I've perfected transportation, and like it's like, no, you haven't. Like, this is broken. Like it. Yeah, so I don't transmit if it's doesn't have a leading zero result, because right now it's just bad for the environment. Like, this is crazy bad. Like, you could run cities on the amount of like energy that we're burning with this stuff. So there's a lot of exciting technologies coming out that aren't proof of work. Well, not a lot. There's a few that are interesting. Proof of stake is a really big one, and that I won't get into it, but.
So Bitcoin uses proof of work.
Bitcoin uses proof of work, and I think Ethereum's moving or has moved to or I think they have a hard fork coming up that's proof of stake. So, and that just means people that own it are the people that can it's tricky, but it's like there's like a weird consensus thing where people that own it have kind of a privilege to make new blocks, and then people have to verify it, and there's some criticisms of it. It solves the computing power problem of that. So I won't even get into this. There's so much, like, once you get the basics, there's like a million different directions we could talk about, and stuff like that. Let me try out some line coding really quick. If anyone wants to sit around, or if anyone wants to see if I can do this really quick and actually do some Ethereum stuff. Is that interesting at all, or see how this thing actually lives? Okay, so so that's actually the code I want. Okay, so a few technologies. So if you're familiar with Node, this won't seem too crazy, but there's this really cool library called Web3.js that you can just npm install. Web3.js. Maybe probably has a different. It's awful. Stop. What is it? Whatever. I already have it installed, so I don't have to worry about that, I guess. So const web3.js equals require web3.js, please. No, don't do this to me. What is it? I think maybe it's just npm install web3. Okay, so this is it. It should kind of like, it's going to throw some, it compiled with Node JIP, so it's going to throw some like errors. Don't worry. I got it to work. I got all this stuff to work with errors, so but yeah, it's kind of like, it'll take just a second. So basically, Web3.js is a really cool technology. Like a lot of newer JavaScript stuff, you can use it in the browser or on the server, in a Node environment, or just like throw in the CDN. That should have. I feel like that should give me errors. I hope I didn't download some garbage. Let's try this again. Okay, maybe I just downloaded a bunch of viruses. What is Web3.js? Okay. I should have already had it in here. Okay, did I? Oh, okay, I got it. So what's Web3.js? What? No. Oh, the file name is, or the module name that I have locally is wrong, but I will live with whatever. Yay, solved it. So it's got a lot of cool functions. I won't get into a lot of this stuff. I think BN stands for big numbers, so a lot of the stuff has to do with working with numbers. Here's the unit map, so the penny in Ethereum. So this is connecting to Ethereum. This is a quick aside. All the stuff I'm really doing right now is in Ethereum, because Ethereum to me is a lot more interesting. It has something called smart contracts, where you can kind of programmatically interact with your blockchain, whereas Bitcoin is more like, I'm just like transactions, money changing hands idea. Ethereum's like, hey, developers, have at it. Make applications that hook into this thing. Do whatever you want. If the weather's 90, you can have regular accounts that are monetary, like people accounts, and then you can also have like programs that have accounts that control it. So there's a lot of like better web dev technology that's kind of built into this stuff. But anyways, here's your like, the ether is that many units. Here's like the penny. You might have no ether, that's bad. And then some of these are just other technologies inside of Ethereum that they're working with to more or less success. So let's connect to a node. And let's do that with Infura. So I don't have a local copy of a full node, but I will log into this cool service. And part of what I'm doing, just because I think this is so interesting, is like I put a limited amount of money in this thing, and I'm just going to be exposing a bunch of API keys and stuff, and then shutting these down after this talk. but I kind of wanted to show people this because I think it's really cool. Let's get the address for my node that that service kind of allows me to connect to. So I have this web thing, so let's call it my web3 equals new web3, and give it to connect to. So now my web3 has a lot of the same stuff, but it also has a lot of new functions. All these kind of get hash rates and all these other things, because now I'm kind of connected to a node. I have kind of a more live object. So let's create an account. You guys want to create an account? Let's do that. So what did I name this thing? What did I just name this? Web3. Why am I doing this? Make this so hard. No, that's not good. My Web3. Okay, so now I have an account. Here is the address and private key. So this is like my credit card number, and this is like my name. So this was, somebody would send me some money with this, and with this other guy, they would, no, I don't want to leave. So let's go ahead and get my address. And there's this other cool technology called MetaMask. It works better in Chrome for some reason. I think it's originally, and so I've got $20 exposing this private key, but because I don't even have access to it with MetaMask. But I've got $20 here in my browser that I can kind of interact with. And basically, if I put Web3.js on it, it can interact with it. Like this injects a bunch of JavaScript before your head even, I think, or like in your head of whatever web page you go to. And it can kind of secretly interact with anything that enables payments through Web3.js. So one thing I can do is send, so let's go check really quick. And before I do this, before I do that, let's just to prove that this is actually happening. What did I call this thing? Account? Yeah. So in Web3, I think I called it my web. Okay. So just for JavaScript purposes, I just got the balance using my address, and I got a callback, and I set the balance to the word balance. So if I use balance, I have no money in this account I just created. One of the things too, just for lots of sense, I can just go ahead, I could make a for loop that runs the rest of my life, and it won't really matter that I'm just generating accounts, because essentially, it's computationally infeasible to create an account that is someone else's account almost. It's like, need multiple dimensions of time and Googles of power to ever recreate this thing. But there's a potential you could. It's just like winning the lottery 1,000,000 times and then transporting back in time and becoming dolphin. Like, it's just really rare. It's probably only happened a few times. So so my balance of my account for this thing I just generated is 0. Kind of makes sense. Let's go ahead and give me some pennies, just to be, or I don't know, maybe $1 or something. Let's send me like 0.001, 19 cents, 38 cents. There we go. Gas is basically, it's like a transaction fee. So along with mining rewards, you have to pay gas, and that basically just converts whatever Ethereum is to current US dollars, and then just gives someone an actual like current US dollar value. So like 10 cents. Like, I'd rather just have something that kind of. Okay, cool. So I think I just got to confirm here. Cool. So I just sent that Ethereum block time. So I've just said something to a transaction pool. It's sitting up there, and what's going to happen is someone's going to pick it up, and oh, looks like I've got a transaction. It already got confirmed. So Ethereum's really quick. Blockchain or Bitcoin's really slow. So I'm on a block now. I'm the next commit, and so essentially here is some information about my transaction. I'm already 2 commits behind. So I'm already 2 commits. And the thing is that usually you have to wait a decent amount of time because you commit, but somebody out in like Spain or wherever could also be making a chain that gets longer than yours. And part of the protocol is you take the longest chain, whatever it is. So I could be confirmed, and then momentarily they're like, oh wait, no, you're not the longest chain, and everyone goes with somebody else, and I go back into the pool. And so usually you have to wait like a certain amount of confirmations before it's like a legit transaction. Was there a question back there, or I just heard? Okay, cool.
Roughly speaking, amount of time, what are we talking?
Transaction or confirmation every 15 seconds. Some things have a certain amount of like some of the exchanges where you like buy this stuff. If you go and try to transfer that money, they say for you'll have to have a certain amount of confirmations before it's a legit transfer. So I think Coinbase, which is kind of the big one in San Francisco startup or whatever, is like 40 transactions for Ethereum. But I think so. I'm at 5 now. And let's see what I don't know what Web3 JS's time limit is, but I think so. I'm going to use the same. I'm checking my balance again, and there we go. I already have it. So that's in like Way or whatever. They're pennies or whatever. So we can. Did I put that in here? There we go. There's a conversion thing I can do in here if I have it real quick. I don't think I put it in there, but I think it's just Web3. Am I calling this thing my Web3? There we go. Or I think it's utils.fromway, and then I do balance. And I think I just say Ether. So that's how much Ether it was, and then Ether is trading at $178, so 35 cents. And if I look at what I gave myself, should hopefully, I think I gave myself 35 cents, 38 cents. I think that rounds. So cool. Now I have money. Now I don't want money. Get transaction really quick. Literally in JavaScript, I can go ahead and make, I can send this back to my account. So it's not just plugins to do this stuff like, where's that? So my Web3, just making sure I'm using the right stuff here. So I'm literally just going to steal this. Let's make a transaction really quick. So I'm going to make this transaction object. Oh, that sucks. Oh, well, it's... Okay, so, and then I guess I'll just write over this raw transaction. And then from is going to be whatever my address is up here. So let's give it back. Transaction. Let's get my address that I think this thing has an address. Oh no, sorry. Get my address. So let's give it back to my account. Raw transaction 2. So let's see raw transaction object. What does that look like? I converted that to hex, but it's originally like 0.001, so hopefully I had that money. Let me just double check that I'm not making garbage here, and this makes sense. I gave myself 0.002, so I should have that money to spend. Let's do this kind of cool. This is just going to be kind of some promisey stuff that So, okay, wait, let's do this. I'll just write it out, it's not that much. So signing, I'm gonna sign that transaction that I have. Raw transaction. And then I'm taking a signed transaction. I'm going to, what is it? eth.send it. Send signed transaction. I'm gonna reference that raw transaction. And then I'm going to get a receipt of that. And I want to just go ahead and receipt. Oh, no. I'm going to go just console.log that. Make sure I spell I before E. And then if I get errors, okay, try this. Click. Okay, so I sent out the transaction, and it's going to console.log me an error, console.log a receipt. And so that's happening right now. So I'm going to wait. I don't think it takes very long. How's everybody doing? Is everybody waiting to leave? If you want to leave, feel free. I think this just takes like a second. This just takes maybe 10 to 15 seconds. Either way, it's going to print out like whether there was an error or that received the message, or if there's like a problem with something I wrote, it'd probably print that. But
So is that just like the node REPL or whatever?
Yeah. So I think I'm not a node wizard. I don't know if somebody is. If like you can do a process and it just runs in the background, because I know that I can start running code right now, and I know also with this thing that eventually it's going to start print. It's going to print something to console. So that seems really weird to me. Like that seems like a thing that can't happen. Like it should be like hanging basically. But I guess if this is kind of like if the promise resolves, it's going to resolve like in the background kind of. Well, let me go see if scan has it. Let me go and see. Or keep doing that. Let's go take a little look here. See if this guy has it. So, no, it hasn't got anything yet. Yeah, maybe I'm wrong. Maybe I'm wrong about this whole thing. If you want to see what it looks like, this really, because I remember thinking, well, that didn't work, and then like a minute later, I got a bunch of stuff to console as I was printing out. Maybe I'm wrong about this. What should or shouldn't work? These work. So the other thing I was going to show, but I think it would just be too much, is with this. Let me just do this one last thing, just to put everything together in perspective and do probably the most important part of this talk, which is you can buy cryptographic cats now with this MetaMask plugin. So essentially, I can go searching for essentially like digital trading cards of animals, and basically I bid on them, and if I win the bid, I think it takes like a second, then it's going to execute some code called a smart contract. That smart contract is going to basically sign over that kitty to me so that people know that I have public ownership of it. But like that's really all it does. So we'll just take the saddest looking cat. Oh, this guy. That guy looks pretty sad. That guy's strung out. This guy's had too much coffee. All right, little buddy. Yeah, I'll take one, please. checkout. So I don't know. I think that's less than $1. MetaMask is like, are you sure you want to do this? And then all right, so I've requested to purchase Buttercup Yankee Eyes, and this takes me back to Etscan, and it takes a few seconds for me to take a look.
Is the fact that you bought a CryptoKitty now part of the blockchain forever?
It is part of the Ethereum blockchain. Yeah, you can, when people 100 years from now, when this thing is still going, are going to be like, why did this happen? And just won't. It's just going to be there. There's nothing. It's immutable. So it's decentralized. No one can stop me from getting this cat. No central point of failure to cat ownership. I mean, this is literally when they made CryptoKitties, the networks, there's a whole series of like messages when the network actually like started going down and nodes started failing, not because there were malicious actors, but because there was too much traffic and there weren't enough full nodes. Like there were too many people trying to buy cryptographic cats, and the network was like failing under the load of that. So it was pretty wild. So this.
I love that you've got a bunch of like people with PhDs trying to make sure this is secure, and then it's they're like, oh, someone's gonna try and break it. Nah, it's just cats.
Yeah. Thank God we built all these incredible data structures and glued all these ridiculously difficult technologies together so we could trade cats. So, if this thing resolves, it'll be cool. If not, whatever.
How do they figure out like how many, like apparently there's no minimum purchase or whatever, right? And then how do they figure out how many transactions are going to be in one block or whatever?
It's a good question. I don't know. You mean no minimum amount of transactions in a block, or no minimum amount of money that can be spent?
Well, there was two things, like,
If you looked at
you did something for 38 cents or 35 cents or something, right? So
Oh.
apparently they don't care that you're just polluting it with a bunch of 3-cent things or whatever.
yeah, no, that's
The miner wants to get the transaction fee, so he gives you the transaction fee.
yeah.
Zero, we have one, you can do it in Ethereum, but you can do it in Bitcoin, I think.
Hmm.
Then nobody would process the transaction because miners don't give it free.
So
But then how many different transactions will sit there until somebody uses one of those, takes that all day to generate this, or it takes $50 worth of energy to generate a signature for 17 cat videos.
Yeah.
You know what I mean?
So part of that is that they are getting paid to put my transaction in their block, and I'm not entirely sure if there's like a limit. I think it's just like you probably want to bundle. I mean, it would probably be good if you wanted to bundle as many available transactions as possible, and because you're. But yeah, I don't know. You definitely would want to privilege like this dude just spent $1,000 and now I'm getting like $20 for a transaction fee, whereas for me it's going to be like 20 cents. So.
Can you incentivize transaction will be taken by increasing the gas fee?
I think you can. I think part of that raw transaction thing was I actually specified the gas that
So it's not a set percentage of it.
it was gas, which was this is like in weight or whatever, which is the smallest unit, which yeah, I don't know why that didn't work. It worked last time, live coding, but I can actually check real quick to see if I get my cat real quick. Ooh, something's happening. Okay, so here's a really cool thing. And this would be like maybe Talk 2.0 if anyone still cares about this or like at another date. And I gave a talk on smart contracts, but they use, instead of an API, use an ABI for smart contracts. So it's an application binary interface. So what you send isn't like normally with an HTTP like REST API or something, you're going to send JSON and get JSON back, and it's kind of this intermediate format we can all use. If I'm writing a backend in Python and someone else is using Scala or something, we can talk using this JSON. With an application binary interface, you actually I basically say I want to call this function on the smart contract and I want to give it these values, and then it compiles to like a byte string a binary string, I guess, and then basically that gets sent. So instead of sending JSON, I'm sending like this binary string that ends up being a function call. So, but smart contracts are kind of tricky. They're cool, but they're tricky. So I do already have a cat. If you look in my MetaMask account, I have like $20 in Ether, but I should also have one CryptoKitty. Oh, I don't want to send it. I just want to look at it. I think I can go back to, let's see what we got here. I don't know if the other one comes up yet. It's going to take, yeah, this little guy. There he is. That's mine, see? That's me. I own Red Velvet. So he's got all these different cool attributes. He just looked like the most pathetic thing, so I figured if I wasn't going to do it, it's kind of... I'll end it there, not to go too far overboard. But thanks for coming, guys. Yeah, we'll just wait and see. I can show you what the output would look like somewhere else. If you guys have any questions, throw them at me. But it's kind of late. I didn't cut this one short or anything, so.
So miners have incentive to snatch up the transactions because they want them to get them, not someone else. And they want to get them encrypted and processed, done within a block so they can get paid. But they also want to batch those many together so they can. Not as many together as they can, but there's like some tension there. You do the math and get it submitted and get money. But you also want to batch them together to make the proof of work worth your time.
Yeah, the bigger thing right now I think is the mining rewards. So you definitely want transaction fees, and you could like really make a decent amount in some cryptocurrencies, privilege mining fees over actual rewards. But like for if you mine blockchain or something or Bitcoin, it's like I think the reward is like 15 Bitcoin, which at $6,000 a Bitcoin, it's not a small amount of money. So it is like mining. You're like mining for gold. There's potential to make a decent amount of money there, but not with the amount of. The thing is that you don't like. There's a lot of stuff that goes into that now, and there is a big question as to whether it's not. For a person like me or you or anybody to actually start your own operation is not economically worth it right now because
Well, we got like capital investment on a mining
operation and like you're never. It's gonna be yeah.
So if you compromise about 50,000 charter modems.
If you have a botnet to use, then an IoT network of fun. So this is what it should have printed out if I had done it right. It would give me a block number, the amount of gas used, right here. I don't know what a logs bloom is. A lot of zeros though, it's kind of cool. Status, and then it eventually shows up in the Ethereum Etherscan stuff. Oh, this may take a while for me to get the cat, but.
No. Do people voluntarily? Is there some a centralized mining network where a bunch of people can say like, well, we don't have all these computers back together and servers in a building, but I'm not using it right now, so sure, knock yourself out and give me my cut.
I know that there are mining pools, so you can go and either make your own or sign up online, and it's usually somebody already has it set up where you can buy a certain amount of like hash, you can buy a certain amount of computing power and be in with a bunch of people so that if any of those computers actually is able to mine a block, then you get a percentage of that reward. And even that now is actually said not to be like economically viable, so it's kind of crazy. But there might be. I don't know.
Is this just because the primes are so large now?
they change it on purpose. So they change the difficulty of adding a block on purpose as time goes on, as the network computing power comes. And it's not that the primes are getting large. It's that we're adding more zeros to that magic number you have to make. So like like in the example, like every time you add another 0 to the front of the to the hash, the result of the hash or the hash that you get, you're multiplying whatever your whatever your chances are by 16. And if it's like a trillion billion chances times 16 is a lot more, that's a lot more work you have to do.
And the bonus gets cut.
Yeah, the rewards are smaller, so hopefully it continues to hold its value, or it'll be. Come on, guy. And then you can breed these things too. It's just ridiculous. I think it costs to breed them, but I bought my first one today, and I'm addicted. I've already bought 2. I have to get more. But I think, for me, honestly, like, I think this stuff really excites me, not because I own any if Ethereum goes through what they call like to the moon or whatever, I'll be able to buy like a new set of golf clubs. Like, I'm not gonna get rich off of the small amount that I own, but it's like, this is really exciting because it could be it could fundamentally change the way the internet kind of works, how we interact and make applications, how what kind of companies we're going to see in the future, or how, like, literally you could, like, there's like a meme out there that, like, in 2000 it's like, hey, the internet's a miracle, and then in like 2017 it's like, hey, let's overthrow the banking industry. It's like, I think there's a lot of skepticism, rightly, that like this isn't going to replace the US dollar or whatever, but to me it kind of makes more sense if you live in a country like, not to get political or anything, but like in a country like Turkey or Venezuela, where there actually is a centralized, like, there are worries about the currency that you own, like, being manipulated or something, or not being able to control the money that you actually own. If you have cryptocurrency, nobody can control, like, your bank account, basically. You don't have to worry, like, it's there. It should be safe if the blockchain is safe. So, like, I don't think it's, like, it doesn't seem as, like, in a place where you don't really have to worry about, like, the value, you're losing tons of value with the money that you have, or like, I'm not worried that my bank is gonna steal all my money or something. Like, I think that'd be kind of crazy, but I think cryptocurrencies have essentially created like a new class of assets to own, and I think it could fundamentally change, like, what kind of technologies and things are available and how people can interact with them in the future. So I think it's really exciting if it works, like, and this becomes more ubiquitous. Like, we could see some really cool things. So that's kind of what gets me excited about it. Is like, it gives the power back to people. Like, you can control your own data now. If you like Facebook, you could make your own Facebook. Like, you could have your own, data, essentially. If you could control the UI and everything, like, then you can have all the messaging data that you would want private, encrypted in certain ways, that, like, can just be public and out there. And everyone's like, all you need is a UI. All you need is a really nice, slick UI that is essentially a JavaScript file now.
I'm a little skeptical about the idea of the back to the people thing, because really you still are dependent on infrastructure. I do believe that cryptocurrency is very useful for foreign exchange, because banks charge an awful lot of money to transfer money to other bank accounts in other countries.
Mm-hmm.
But as far as you're still dependent on probably big actors who are in this game, and the idea of people will turn to, let's say, Venezuela, if the currency collapses, people might turn to that. But you're still going to have to pay fees and whatnot. It's going to be volatile.
Mm-hmm.
And I don't think it's going to be, it's going to be like really the days in the 19th century
what do they call it? Or companies did scripts or whatever.
Well, no, well, that's
Script?
it too.
Oh, yeah.
Each bank, and sometimes you go to South Carolina, you had notes from New York, I'm sorry, we don't take those.
Yeah. But I mean, you can very easily exchange cryptocurrencies for cryptocurrencies, and there is a large market right now in crypto for foreign exchange.
But
They have that one crypto coins like it's worth $1. It's like
Ripple.
Ripple, is it Ripple? So
Yep.
it doesn't fluctuate. It's just how much you have.
It does kind of fluctuate. It just hovers around $1 because there's so much of it. That small change, like if you had, like, imagine if you like the price, if you had a cryptocurrency that only had 2 coins and it fluctuated in value from like $1 million to $1 trillion, your value of your one coin would go from $500,000 to $500 billion. Like, you'd be like, oh my gosh, so volatile. If you have 1 billion coins and your value fluctuates wildly, your coin is going to stay a lot more stable, or it's going to look like it's not shifting as much, but like percentage-wise, it's still, if I own 1 million of $1 coins and it's worth 70 cents tomorrow, then I own 70% of what I just, it looks like it's the same. But it's,
It's Tether. I think it's Ron Ripple or something. Where it's actually they hard lock.
oh yeah, it is. That's right.
Global money transfer to say if you own this coin, right? It's only they only do. I don't think you can own half, so you can own whole, and then they're all worth the same amount. So you always know you're not ever worried about like, oh, I bought a Bitcoin for $6,000, it's worth $300 today. That was like crazy. Yeah. And nobody minds it. They just like Tether just
And-
releases more onto the network as it.
Yeah, I don't know a whole lot about Tether, but there's definitely like a lot of interesting stuff going on with that. I know that Ripple's used a lot for foreign exchange. This was the idea behind that, but I don't. It's actually like not technically like decentralized in a weird way. So yeah, I guess. Well, I got the error statement, so there we go. Yay. Be aware that it might still be mined. Hey, maybe it's. Transaction was not mined within 750 seconds.
So does it have a function of just being on the event loop or whatever? Is that what it is? The fact that the other process waiting for the promise was off the event loop waiting for the promise, and then he can run out of code and however long it takes for the promise to return before it be put back on the event loop and ready up.
Yeah, it's like we cleared out the callbacks from promises were pushed into the task list and finished out finished out the stack, and then we were just waiting for those resolved events to go out.
But anyways, I'll post if I ever get that transaction, if I ever get back. But I'll post it in the Full Stack Web Development channel. But like no, it's fine. Like, I guess the point in showing that example is that like you can programmatically. I mean, with JavaScript, I can go ahead and connect to a full node and start trading cryptocurrency if I have someone's address and they use a way to essentially. The idea behind MetaMask is that it'll sign these things for me, and I don't have to worry about having users wander around with private keys or whatever. Like, you wouldn't really want that. You know what? I probably have a low gas price, but no, it's showing up, so that's cool. Yeah. I mean, you could. I mean, it's not like incredibly complicated code to write if you're you could throw this into like there were a lot of questions I saw today about like integrating Web3.js with Vue, or like other things with Web3.js. But it's not incredibly hard to use this stuff when there's so many tools out there. As far as like smart contracts go, there's like 3 different languages, and they're actually executed on their own virtual machine. So like it's like the JVM essentially. And you just, anyways, I don't know. I'm going off on a tangent. I can talk about this stuff for too long, but yeah, if you're ever interested in developing it, Ethereum is definitely a language I would point people at because it's the most developer friendly. Their community's really, they're doing a lot of changes. Bitcoin's more like stable, and there's the market cap for Bitcoin is like over $100 billion. So there's probably a lot more interesting activity on that. But I think as far as like developer friendly stuff, like Ethereum is very incredibly easy to interact with. Anyways, I'll let you guys go.
Thank you, man.